All right, everyone, welcome. So, every single one of us in this field, whether you're just starting out or you've been doing this for years, has faced that same moment. You know the one I'm talking about. You're staring at a blank sheet of paper and you have to design a complex power system. It's daunting, right? Well, today we're going to pull back the curtain on the blueprint. This is the master plan that takes all that complexity and breaks it down into something you can actually manage.
I mean, just think about it for a second. The charger for your laptop, the guts of a solar inverter, the drive system in an EV, these are all incredible pieces of power electronics. But designing one from absolute zero, from nothing, it can feel, well, almost impossible. So the big question is, where on earth do you even begin? The good news, there's a method to the madness, a system that all the pros use.
Yeah, it's pretty simple, really. You wouldn't just start throwing bricks in a pile and hope a house appears, right? Of course not. And you don't just grab a soldering iron and hope a power converter materializes. No, you start with a plan, a blueprint. And honestly, this is the thing that separates a design that works from a pile of smoking components. So let's break it down.
Okay, so this master plan, this blueprint we're talking about, it's built on what I like to call the 4 pillars of design. And here's the beautiful part. It doesn't matter how complicated the final system is, you can always break the design process down into these 4 key areas. If you can get your head around this, you'll have the key to go from an idea on paper to a real working piece of hardware.
And here they are, the 4 pillars. Number 1, design of the power circuits. 2, protection of your power devices. 3, figuring out your control strategy. And 4, the design of the logic and gating circuits. Now look, these aren't just some random steps I made up. This is the core framework. Every single design you will ever work on will touch on all 4 of these. So let's really dig into what each one means. First up, Pillar 1, the power circuit itself. This is the heart of the machine. I want you to think of this as the engine and the drivetrain of your car. It's the big, chunky hardware, right? The inductors, the capacitors, your big power switches like MOSFETs or IGBTs. This is the stuff that does all the heavy lifting, the actual moving of energy from one place to another. Everything about your system's performance starts right here. Okay, so you've got a powerful engine. Great. But what good is a Ferrari with no brakes? It's useless, and it's incredibly dangerous. That brings us to Pillar 2, protection. This is all about making sure your beautiful design doesn't destroy itself the first time you turn it on. We're talking about everything from fuses and snubbers that handle nasty voltage spikes to the really critical stuff like thermal management. You know, the heat sinks that keep your expensive silicon from literally melting. Trust me on this, if you skimp on this part, your design will fail. Spectacularly.
All right, we've got the muscle, we've got the safety systems, but who's driving this thing? What's telling it what to do? That's Pillar 3, the control strategy. This is the brains of the whole operation. It's the algorithm, the intelligence that's constantly watching what's happening and making decisions. It could be a simple feedback loop or something way more complex. But at the end of the day, this is the part that makes sure your system is actually doing what you designed it to do. And that brings us to the final piece of the puzzle, the one that ties it all together. The brain, our control strategy, is making all these smart decisions. But how do those thoughts actually make the muscles move? Well, that's Pillar 4, the logic and gating circuits. Think of this as the nervous system. It takes those tiny, low-voltage signals from your microcontroller and turns them into the powerful, precise pulses needed to tell those big power switches when to turn on and off. Without this, the brain can't talk to the engine. Okay. So we've got our 4 pillars. We know the what, the 4 things we have to design. But that still leaves the big question of how. And this next part is a really crucial pro tip. This is the secret to not getting completely overwhelmed by the details when you're just getting started.
So when you sit down to design, you're immediately faced with 2 different worlds. Over here, you've got the ideal world from your textbook, right? Everything's perfect. Switches are instantaneous, there's no resistance, no stray inductance, it's all clean and beautiful. And then you've got the real world, a messy, complicated place full of delays, parasitic effects, and losses everywhere. So which world do you start in? Well, here's the secret. You absolutely do not start in the messy real world. You start with the ideal model. And this isn't just my opinion. Listen to what the textbook says right here. This simplified analysis is, and I quote, very useful. And it's not about cutting corners. It's about clarity. It lets you figure out the fundamental way your circuit should behave and nail down your control strategy before you get bogged down in all the messy real-world stuff. Think of it like this. You build the strong, simple foundation of a house first.
By starting with that ideal case, you get the basic math right, you understand what the waveforms are supposed to look like, and you get your control working perfectly. Then, once that foundation is rock solid, you can start adding the complexity. You start accounting for the real-world stuff, like switching losses and voltage drops. But you're doing it from a place where you already understand how everything is supposed to work.
So, this whole thing, the 4 pillars, and this idea of starting with the ideal model, this is your roadmap. This is your path forward. And I don't just mean for my class, I mean for your entire career. This is the mental toolkit you're going to use to tackle any design problem, no matter how scary it seems at first.
So let's just boil it down. What's in your essential toolkit now? 2 things. First, the 4 pillars of design: power circuit, protection, control, and gating. Use them like a checklist so you never forget a crucial piece. And second, the ideal first approach. Always start simple, get that solid understanding, and then add in the real-world complexity. That's it.
So I want to leave you with a question to think about. You have the blueprint now. You see the 4 main parts. So which one gets you excited? Are you drawn to the raw power and physics of the main circuit? Or maybe the critical, high-stakes challenge of protection? Maybe it's the elegance and intelligence of the control algorithms, or the lightning-fast precision of the logic and gating circuits. Seriously, think about it. Because your answer to that, well, that's probably the first step on your own path as a designer. All right, now go figure it out.